Good evening, students.
Good evening, ma'am.
Okay. So we were discussing about the resolution of vectors. So continue with the same topic. We are just starting the topic resolution of vectors. We must have an idea about the resolution of vectors. Then only we get the idea of component form of the vectors. Then only we can discuss or explain the method of vector addition using component method. Okay. So let us continue with the same topic. Resolution of vectors. Resolution of vectors. So as we told earlier, the term resolution of vectors means splitting of vector into two or more components. The splitting of a vector into two or more component is known as resolution of vector. So as we discussed earlier, suppose if we are consider a vector that is vector A with a magnitude small a, we consider another vector, vector B with a magnitude B. Then we know that according to triangle law of vector addition, the third side represents the resultant vector. The third side represents the resultant vector. So here capital letter A is the resultant vector. And it has two components. We split the resultant vector A into two components. One is small letter A and other is capital letter B. Sorry, small letter B. So the resultant vector A is the sum of small letter A and small letter B. So capital letter A, vector A is equal to vector A plus vector B. It is the sum of vector A and vector B, because here we split the main vector or the resultant vector A into two smaller parts. One is a vector A and other is vector B. Again, the splitting is possible. Again, here we can split this vector B. Here we consider another vector, mark it as vector C. So, and this is our another vector, this is our vector D. Okay. So here we can write vector B is equal to vector C plus vector D. Then our equation 1 becomes the resultant vector A is equal to small letter A plus, instead of B, we can substitute this value, that is vector C plus vector D. Vector C plus vector D. So the resultant vector A becomes split into three components or three terms. So initially the vector A is split in terms of two, that is small letter A and small letter B. But again, in the second case, we again split the resultant vector A into three, that is A plus C plus D. Is there any changes occurs to the resultant vector? Is there any changes occurs to the resultant vector in both cases, in first case and the second case? What will be the resultant vector here? What will be the resultant vector?
No change.
No change. No changes occurs. Even we are splitting it into two, the resultant vector is capital letter A. Vector A is equal to vector A plus vector B. Again, we subdivide or split this vector B into two in terms of vector C and vector D. Even though the resultant vector will be the same, there is no changes occurs to the resultant vector. The resultant vector will be the same, that is vector A. So this is what is known as resolution of vectors. Resolution of vectors means the splitting of a vector into two or more components. And as a result, there is no changes occurs to that of this resultant vector. So now we can see the definition for the resultant resolution of vectors. What do you mean by resolution of a vector? Resolution of a vector is the splitting of a single vector into two or more vectors in different directions, which together produces a similar effect as it is produced by a single vector itself. Up to here is the definition for resolution of a vector. And this point you can write as a characteristics of a resultant vector, or as formed as a result of the resolution of vectors. Resolution of a vector is the splitting of. So by this term, resolution we indicates or we implies it is a splitting of a single vector into two or more different components, into small components. The resolution of a vector is the splitting up of a single vector into two or more vectors in different directions. And the resolution of vectors can be done if and only if the vectors are inclined at an angle theta. Is possible, that is the resolution of vectors is possible if and only if the vectors are inclined at an angle theta. Suppose if we have two vectors, vector P and vector Q, they are lies along the same direction. But here the resolution of vectors are not possible because the angle between them are equal to 0. Similarly, if we are consider the two vectors, they are lies in exactly opposite direction, then what will be the angle between that two vectors? If we have two vectors which are lies in the opposite direction, what is the angle between the two vectors?
Theta.
Angle theta is equal to? Yeah, it's right. Unmute and say, John. If they are along, theta is equal to 180 degree. If the two vectors are in the same direction, the angle theta between them is equal to 0. So we cannot resolve that vectors into, or we cannot split the vectors into two. And if the two vectors, they are lies in exactly opposite direction, the angle between these two vectors are equal to 180 degree. In that case also, we cannot split the vector into the small components. But here, if the vectors are, or if the single vector which is inclined at an angle theta, then we can split the vector into two parts or two components, not only in two, but also in two or more components. So the splitting of a vector into two or more vectors in different directions are called resolution of a vector, and which together produce a similar vector. There is no change in the resultant vector. The resultant vector will be the same. It is vector A itself. And this resolution of vector is possible if and only if the vectors are inclined at an angle theta. Is it over?
Yes, ma'am.
Okay. Now again, here we consider a vector. Suppose if it is vector R, the resultant vector R. Now I am going to split this resultant vector R into two. One is P and other is Q. Okay, so here we have a resultant vector, vector R, or we have a single vector, vector R, which is inclined at an angle theta. I split this resultant vector R into two. One is vector P and other is vector Q. So here we can say vector P and vector Q are the components of resultant vector R. Or we can write vector R is equal to sum of these two vectors, vector P plus vector Q. That is what is we were discussed here. But all of you please listen here or please observe what is the speciality between these two vectors, the splitting vectors, vector P and vector Q. What is the angle between them?
90 degree.
Yes, the angle between these two vectors are equal to 90 degree. So here we are going to introduce a new term. If we are split a single vector, so here we consider a single vector as R, and we split the single vector R into two. One is vector P and vector Q. That is, they are mutually perpendicular to each other. So if we are split a single vector into two and the angle between these two vectors are equal to 90 degree, then we can call these vectors as rectangular components of a vector. This is what is known as rectangular components of a vector. So if we have a single vector, here we have a single vector R. It is split into two. One is vector P and vector Q. And what is the condition here? If the angle between these two vectors are equal to 90 degree, then we can call them as rectangular components. So whenever we resolve the vectors or in the process of a resolution of vectors, if the splitting vectors are mutually perpendicular to each other, then we can call them as rectangular components. That is what we are going to write next. Rectangular components. So before that, you just write a definition for what you mean by components of a vectors. The part of the vectors obtained after splitting the vector are known as components of a vector. That is what is known as components. So here we have a vector, vector R. We split the vector into two. One is vector P and other is vector Q. This is vector Q. The part of the vector obtained after splitting the vectors are known as components of a vector. This is what is the definition for components of the vector. We need this definition, then only we can explain the vector addition using component method. So here we split the resultant vector R into two. One is vector P and other is vector Q. So what are the component vectors are here? What are the component vectors?
Vector Q and vector P.
Yeah, vector P and vector Q. So because here the given vector is R, the single vector is R, we split that single vector into two. One is vector P and vector Q. Then the parts of the vectors obtained after splitting the vectors. So here the vector R is split into two. Vector R is equal to vector P plus vector Q. The part of these splitting vectors are known as components of the vectors. So here we can say that vector P and vector Q are the components of the vector R. Are the components of vector R. The parts of the vector obtained after splitting the vector are known as components of the vectors. The parts of the vectors obtained after splitting the vector are known as components of the vector. Now we can write what you mean by rectangular components of a vector. So in the previous slide, we discussed what you mean by component of a vector. So if a single vector is split into two parts, that's parts of the vector that we are splitting is known as components of a vector. Now, what do you mean by rectangular components of a vector? If the components of a given vector are perpendicular to each other. Perpendicular to each other means if the angle between these component vectors are equal to 90 degree, they are called rectangular components. Here we have vector R, the resultant vector, or it is a single vector. We split it into two. One is vector P and other is vector Q. So here vector P and vector Q are called components of a vector. And what is the condition for rectangular components? If the components of a given vector are perpendicular to each other, that is the angle between vector P and vector Q is equal to 90 degree, then we can call it as rectangular components. So based on this concept, we are going to introduce the vector addition using component method. So this is the basic idea behind the component form of a vector. So the basic idea means the resolution of vector. We can split any vector into two or more different vectors. The process of splitting of any vector into two or more vectors are called a resolution of vectors. After splitting a single vector, we get two or more small vectors. That vectors are known as components of a vector. And if the components of a vectors are lies perpendicular to each other, that is the angle between the component vectors are equal to 90 degree, then we can call it as rectangular components. Is it clear? Do you get an idea about component form of a vector? Component means the simple parts or the small splitting parts of a major vector. There should be a single vector will be there. Initially, we have a single vector. We split the single vector into its component parts or into its smaller parts. That splitting of vectors is known as the resolution of vectors. After splitting of a single vector, we get some kind of small vectors. That small vectors of the single vector is known as components of a vector. And if the components of the vectors are lies mutually perpendicular to each other, then we can call it as rectangular components. Is it clear?
Yes, ma'am.
Yes, ma'am.
Okay. So now we can discuss vector addition using component method. Vector addition using component method. This is our third method of vector addition. Actually, this vector addition using component method is a theoretical portion. After the end of this theory portion, we are deriving a small equation. That is what is the vector addition using component method. So in order to explain this vector addition using component method, here we consider a vector A with the magnitude A. Consider a vector A with magnitude A, which is inclined at an angle theta. Here we consider vector A. Now it is not representing a vector. If and only if we draw the arrow mark, then only it is representing a vector, because a vector is a physical quantity which possesses both magnitude and direction. Okay. So here we consider vector A with the magnitude A, and it is inclined at an angle theta. So this vector A is inclined at an angle theta. So is it possible to split the vector? Is it possible? Yes. Surely we can resolve this vector A into two parts, or we can split it into two parts. Okay. So here we are going to split this vector A into two vectors. So here we consider vector A with the magnitude A, which is inclined at an angle theta. Then by the resolution of vectors, we get the corresponding component vectors. By the resolution of vectors, we get the corresponding component vectors. Resolution of vectors means you just kept your mind, it is nothing, it is the splitting of vectors. So by the resolution or the splitting of this vector A, we get the corresponding component vectors as here we get two component vectors. After that, we can give the name. So here we have a vector A with the magnitude A, which is inclined at an angle theta. Since it is inclined at an angle theta, we can resolve them into two components. One is a horizontal component and other is a vertical component. Okay, so here we are resolve the vector A into two components as a horizontal component and a vertical component. So here we resolve this vector A into two components, horizontal component and a vertical component. Since the angle between these two components are equal to 90 degree, since the angle between these horizontal component and vertical component, since the angle between these two components are 90 degree, we can consider them as a rectangular components. Since the angle between them is equal to 90 degree, we can consider them as the rectangular components. Now we assume these components are lies. Now we assume these components are lies along the x and y directions respectively. Now we assume these components are lies along the x and y direction of a coordinate system. Now we assume these components are lies along the x and y direction respectively. Then suppose the coordinates of this vector A is taken as AX, AY. Then suppose the coordinates of this vector A is taken as AX, AY. This is actually the basic mathematics that we are explaining maths. In maths, we are taking a coordinate system. Suppose you are just imagine if we have a vector with values 4, 0. Coordinate axis as 4, 0. This 4 is corresponding to x-axis and 0 corresponding to which axis? 0 axis, right? Similarly, here we consider our horizontal component and vertical component along the x and y direction. Then the coordinates of this vector A is taken as AX, AY. AX, AY. The coordinates of this vector A is taken as AX, AY. That is, this AX is representing the length of this x direction. AX is from 0 to this point. It is representing AX, the length of the x direction. Similarly, what about this point represents? The coordinates of vector A is given by AX, AY, where the corresponding point is marked as AX. Similarly, here we have this point is represents AY. It represents the distance from origin to AY. The length of this magnitude or the magnitude is given by AY along the y direction. Along the x direction, its magnitude is given by AX. Now we can recall about the unit vectors. We are going to recall. So this length is given by ax and here it is ay. Now we are going to recall about unit vectors. What do you mean by unit vectors? Unit vector. We have nearly 10 different types of vectors are there. What do you mean by unit vectors?
Magnitude is 1.
Yes, unit vectors are those vectors with magnitude is equal to 1. That is what is known as unit vector. Okay. And what is the equation for calculating unit vectors? We are representing the unit vector with the help of a cap. A cap is used to represent the unit vectors. So what is the general equation for calculating the unit vectors? A cap is equal to, or x cap is equal to,
vector x by magnitude of vector.
yeah, the general equation is x cap is equal to vector x divided by magnitude of vector x. But here we consider the vector as a. So we can represent this equation for unit vector in terms of this vector a. So here we are recalled the unit vector. According to unit vector equation, we know that unit vector x is equal to vector x divided by magnitude of vector x. Then unit vector corresponding to this vector a becomes a cap is equal to vector a divided by magnitude of vector a. A cap is equal to vector a divided by magnitude of vector a, which implies vector a is equal to, the resultant vector a is equal to magnitude of vector a into a cap. Let us rearrange the equation. A cap is equal to vector a divided by modulus or magnitude of vector a, which implies vector a is equal to, we bring this magnitude of vector a into LHS. So it becomes multiplication. Vector a is equal to magnitude of vector a into a cap. Okay. Again, here we consider coordinate system, that is ax is along the x direction, ay the vertical component, that is along the y direction. In the previous class we mentioned the unit vectors corresponding to x-axis, y-axis and z-axis. Did you remember the unit vectors corresponding to x, y and z-axis? Any idea? What is the unit vector corresponding to x-axis? Unit, yeah, very good. Unit vector with respect to x-axis. With respect to x-axis is I cap. Good. Unit vector with respect to y-axis.
J cap.
It is j cap. Then what about unit vector with respect to z-axis? K cap. Okay. So we know that the unit vectors with respect to x-axis, y-axis and z-axis, they are I cap, j cap and k cap respectively. But here we not need this third axis because here we are consider only the two axes. One is along the x-axis and other is along the y-axis. In our previous figure, we are consider the vector, we have split the vector into two components. One is taken along the x direction, other is taken along the y direction with the magnitude ax and ay, right? And here we recall the equation for the unit vector. The unit vector is given by a cap is equal to vector a divided by magnitude of vector a. From this, we can find out this vector a. Vector a is equal to magnitude of vector a into unit cap. Unit vector a. That is any vector. Any vector can be represented in terms of magnitude of that vector into unit vector of that corresponding vector. So similarly, here we want to find out these two vectors. Here we have two vectors are there. That is the vector components along the horizontal axis, vector components along the vertical axis. So here we are going to represent the vector A in terms of vector components and scalar components. Okay. Suppose the unit vector along the x-axis is I cap, along the y-axis is j cap, along the z-axis is k cap. Okay. So here we have vector AX is there. Vector AX. Can you represent vector AX? According to our general equation, we know that vector A is equal to modulus of, that is magnitude of vector A into unit vector A. Similarly, can you represent this AX, vector AX? What is the magnitude of vector AX? Magnitude of vector AX. We know that if you have two vectors, vector P and vector Q, vector P is with the magnitude P, vector Q is with the magnitude Q. Similarly,
AI cap.
yeah, it is AX. The magnitude of vector AX is nothing, it is AX. And what about the unit vector of AX? That is the unit vector along the X direction. What is the unit vector along the X direction? It is I cap. So AX, I cap. So this is obtained from the equation for unit vectors. From the equation, we know that vector A is equal to magnitude of vector A into A cap. Unit vector A cap. So here we have two component vectors are there. They are vector AX and vector AY. We need to represent them in terms of these vectors. So vector AS become AX into unit vector I. Similarly, vector AY, that is the component vector along the y-axis. We are split the vector A into two. One is AX and AY. So AX is represented like this. Now the vertical component that is taken along the y-axis is represented by vector AY. What is the magnitude of vector AY? Magnitude of vector AY?
AY j cap.
AY. And here this AY is taken along the y-axis. The unit vector corresponding to y-axis is j cap. So AY j cap. So this is the horizontal component of the vector A along the x-axis. So vector A is split into two vectors. Actually, they are vector AX plus vector AY. Okay, it is split into two vectors, that is vector AX and vector AY. Now the vector components, we can write the vector components and scalar components of this vector. Vector components. Vector components of vector A. Vector components of vector A along x-axis. Along x-axis is AX I cap. AX I cap. Along y-axis is AY j cap. Okay, so any vector quantity can be represented by terms of their magnitude unit vector. This is the general equation, magnitude and unit vector. So the vector component of this vector A along x-axis is given by AX into I cap. Similarly, vector component of vector A along y-axis is given by AY j cap. These are the vector components of vector A. Vector components of vector A. Now, what about the scalar components? Scalar components of vector A. What do you mean by scalar? Scalar quantities. They have only magnitude, no direction. Scalar components of vector A. Along x-axis, it becomes, any idea? We only need to consider the magnitude, no need to consider the direction. So which part is present? Yes, it is AX. Very good. Along y-axis, it is AY. Here we don't need to consider the unit vectors because unit vectors are only used to represent the direction of a vector quantity. So magnitude and unit vector is corresponding, it is representing the vector components. But in the case of scalar components, we only need to consider the magnitude of that particular vector. If it is a vector AX, we only need to consider the magnitude. That is represents the scalar components of a vector. So according to vector addition by component method, the equation becomes vector A is equal to AX I cap plus AY j cap. Vector addition using component method. Where vector A is the single vector, AXI and AYJ are its components. Okay, so this is the equation for vector addition using the component form. This is in the case of two dimension. Here in this chapter, we are discussing about the motion of an object in a plane. If the motion of an object in two dimension, the equation becomes vector A is equal to AXI plus AYJ cap. AXI cap plus AYJ cap. Similarly, can you form an equation for vector addition using component method in three dimension? What about the equation for three dimension? The space is here. I want the equation only. Vector A is equal to
AX I cap plus AY j cap plus AZ k cap.
Exactly. Very good. AX I cap plus AY j cap plus AZ k cap. We need only this equation. For that, we make all these complicated derivations and all. Okay, you only need to study these two equations. Vector A is equal to AX I cap plus AY j cap. This is the vector addition using component method in two dimension. Similarly, the vector addition using component method in three dimension, the equation becomes vector A is equal to AX I cap plus AY j cap plus AZ k cap. So whenever we do the problems, it will be more clear. I will give you one equations, then it is more clear to you. The questions will be like this. If vector A is equal to 5i minus 3j, we want to calculate the magnitude of the vectors. 5i minus 3j. Suppose the questions are like this. Vector A is equal to 5i minus 3j. 5i cap minus 3j cap. So here we can say that the object is moving in two dimension because here only the two dimensions are mentioned. One is the I cap is represents the motion of an object along x direction. 3j cap, it is represents the motion of an object along the y direction. And here we are asked to find out the magnitude of vector A. Magnitude of vector A is given by root of 5 square minus, 5 square plus minus 3 the whole square. We can do the numericals. You don't need to copy down this problem. I will give you more examples. Okay, I will give them examples in our next class. So just to try to thorough with this equations, vector A and vector A for calculating in 2-dimension and 3-dimension. In 2-dimension, the equation is of the form vector A is equal to ax I cap plus ay j cap. In 3-dimension, it is vector A is equal to ax I cap plus ay j cap plus az k cap. Okay. This is the general equation for vector addition in using component method. Vector addition using component method. I will give the numericals in the next class. There will be one more method is that to find out the magnitude of vectors, then only we can do the numerical. That is why I am skip that problem. So we can take that portion in our next class.